All right, we are recording. Hello, everybody. Welcome to the February 24th libp2p sync. If you have any agenda items, please add them to the doc, and we will take them first come, first served. If we don't have any of those, we will jump into weekly updates. Oh, and with that, there are no current agenda items. Also, please add your name to the attendees list, and we will get started on weekly updates. I will go first. Yeah, so was out mostly last week at the IPFS Team Week, working through some stuff. We started planning out content routing improvements through, I think, June. So I'm going to be working on getting those posted in the public forum so we can kind of better see the roadmap of where we're headed at for the next 4 months. Other than that, just minor bug fixes for JS, and then working more heavily on interop testing for the upcoming Go and JS noise implementations. And then other than that, I'll be spending the rest of this week focused on unblocking people on PR reviews, and then the noise work. Anybody have any questions for me?
Just that if when we do the other handshake patterns for the interop testing, we just need to add options to the daemon. And I think there's maybe if you want to ping me about that later, we could. I think there's one thing missing from the noise code that we need to expose. But yeah, there's cool. I think it's the key pair needs to be serializable. But anyway.
Right, for the static keys.
Yeah, exactly.
Yeah, cool. Yeah, we'll sync offline.
Sweet.
All right. Next up, Raul.
Yes, I was caught in IPFS Team Week last week. Besides that, this week I'm going to be, so we started an initiative with the Resilient Networks lab to look at ways to secure Gossip Sub, both for Filecoin and Ethereum 2.0. I'm going to be delving into that this week, along with Viso, David, and Yanis and others. And why probably, sorry, the document is like moving. We're gonna be shipping test ground, the 0.2 test ground release, probably today, and we're gonna start planning for test ground 0.3 starting tomorrow. Then I'm gonna be working closely with Youssef to land Go libp2p noise finally, and to design and land the potentially address provenances attribute in the PS store, which is an item that I just added to the agenda because I would like to discuss this briefly with you guys. This is basically an outstanding item to be able to merge a well-rounded version of signed peer routing records based on some feedback that we received from IPFS and some elements of textile as well that we need to consider, textiles architecture and other uses. We're going to be reviewing Will's alternate PRs as well, and Arsh's PS for persistence PR, and the other PR for the routing table dissociation for the connection table. Any questions for me?
Nope. And with that, let's make sure we get to those. So we'll switch back to the agenda for now. Do you want to go over those items?
Do you want to do that now, or should we do?
Yeah, I want to make sure we leave time for that, right? Because the async updates aren't as important as using the sync time to solve those problems.
Mm-hmm. Okay, so that means that we should do it now. Yeah.
Yes.
Okay, so two items. Address provenances. Okay, so the thing here is that do you want me? Should I explain it, or would you like to explain it yourself?
Yeah, I can explain real quick. So there's a few things. Like right now, the current way the routing records thing is set up is you have the existing interface, which accepts unsigned addresses like it always has, and we have a new interface which takes peer records. And the current behavior is it will replace any unsigned addresses, and from that point on, you will stop accepting anything but peer records. So like you're all in on peer records when you get the first one. But what if you want to explicitly dial an address because the user typed it in at the command line? We didn't think about that exactly. because like now that you have this peer record in, the peer store is not going to accept it, and then the dialer will not be able to access it. Like we just basically need to be able to accept addresses that we're like locally confident in. And also like Textile is having, they're going to be, or they already are, I think, disseminating multi-addresses in their own sort of signed record format. So that's another trusted format that they might want to track the provenance of those addresses separately and be able to say like, oh, we're going to favor the ones that came in through our special format, but we don't really have any provision for that now. So the idea is like, we will add this like a little enumeration, I guess, with the ability to add like your own custom type and say like, the system values would be like maybe came from a peer record, came from the existing unsigned interface, you know, or came from some, I mean, whatever, we can spell out all the places we think addresses are likely to come from. One that occurred to me that I hadn't really thought of at all was DNS link redirects, where we're resolving a name from some other source. Now we have a new address that wasn't signed, but we trusted the name. So we trust this sort of by association. Anyway, the point is, we kind of need to figure out the API for this. We can have defaults for all the current methods, like anything that's going in through adders right now can have a default value, and anything that comes in through a peer record will have that value. And then we need to be able to explicitly specify the value and then do something with, like, expose those, you know, in an API so you can tell where did this address come from. Then what do you do with that information, I guess, is another question. Like, does the dialer prioritize certain origins over others? We may eventually have to figure that out. But I think the point now is just first making sure we don't break anything, but with this restriction on like, we're not going to take your addresses anymore if we have a peer record. And then, but once we've removed that restriction, well, then how do we tell what the good addresses are, I guess, is the problem. I'll stop talking. I think I'm kind of like going on a loop here.
No, that's great. Thanks. Thanks for the overview. So the way that we're thinking in terms of API is the component that will need to. So by default, the dialer will just use every single address that is found in the peer store, no matter what the provenance is. This is to preserve backwards compatibility. But then a subsystem that's opening a stream or that is specifically connecting to a peer by calling network connect, will be able to provide options. We need to add the support for options in dials. And one of those options would be the kinds of addresses or the provenance of the addresses that you want considered for that dial. So basically by defining, as Yusuf said, a enum type, or basically a type in Go, which by definition enum types are not sealed. So this means that any application, like for example Textile, can define custom types, custom enum types, and whenever they add addresses that they've consumed from their custom record, for example, or a custom system or whatever they want to register the particular provenance for, they can just pass in that enum type. And whenever they want to perform a dial and they want to explicitly just use the addresses that have been authenticated by that record, or whatever addresses that were inserted by virtue of consuming that record, or with this particular attribute, they can just tell the dialer. So this is the way that we currently thinking about this, and this way the DHT as well, whenever it tries to, whenever it opens a stream, which implies a connection if one doesn't exist, will be able to pass in the criteria for filtering the addresses that it wants. So a secure version the version of the DHT that we're building, so the one that's shipping in 0.5, will just use signed peer records, and that's it, right? Whereas IPFS, yeah.
May I make a suggestion? So one way we can pass options to the dialer is through context options. This is how we pass the non-dial option.
Yeah,
this could
that's
be the
another
cleanest interface,
possibility.
so we don't have to break the interface or anything.
Yeah, that's another possibility. I particularly don't like this option. I think hacking and like the context could grow indefinitely, and it could become very messy. And it is already the case because we kind of like already took the path of least resistance to introduce dial options by hacking them into the context. And I don't want to perpetuate this approach, but that's my current thinking. I don't know what others think. That's what I would propose in a PR, to actually model and go ahead and model dial options as they deserve to be modeled. Is there's going to be more down the line. But yeah, any other suggestions? Any other input? But things are going to get more defined once you see them in code. So, yeah.
I mean, functional dial options should not have backwards compatibility issues. That should be some easy way to do it.
Is there going to be like a design in an issue for this, or is there already a design in an issue for this?
No, I can write one up after this call. I've got, yeah, I think I have a decent understanding of like what we need to do. So I'll tag everybody on it. Or I'll just drop in Slack.
Yeah, we're also looking to do an overhaul of the Peer Store in JS very soon. So it would be good to sync on this beforehand, just in case we have things that we would like to do in both.
Yeah, and that I guess leads me to the second point, the second agenda point, which is pinning. Another functionality that we need to introduce desperately in the Peer Store. So yeah, so this is kind of like, I'm dancing around with some ideas of that were proposed and floated for Peer Store version 2 as well. But like these are urgent needs right now. Basically the functionality that we want to propose, that Arsh and I have been thinking about, and Stephen as well has been in the discussion and Will as well. Basically, we need a way to signal to the Peer Store that a particular subsystem is needing to keep addresses alive for a particular peer, because they're holding a reference to that peer, and it's important for their operation. Right now, what happens is that when a peer disconnects, identifier will just set the TTL, force the TTL for all addresses of that peer to 10 minutes, which is also an arbitrary number. And like we all agree that TTLs are probably shouldn't be modeled externally in the Peer Store. But yeah, like let's assume that any deeper changes in terms of removing the TTL from the interface and like making the Peer Store a lot more event driven are going to be like punted to version 2. The question is, what can we do right now to make sure that addresses are not changing under our feed, right? And addresses are being removed from under our feed and being like just disappearing and vanishing suddenly. So basically the idea here is to introduce a pin and unpin method on the Peer Store that will ref count, that will be driven by ref counting, such that subsystems can ask the Peer Store to pin a set of addresses until it's stalled otherwise via an unpin method. The question here becomes, hey, what if subsystems are badly behaved, subsystems are buggy, and they just let pinned addresses build up? At one point, that could build up a lot of garbage in the Peer Store. So different ways to go about this are to basically make the pinning and unpinning, make the pinning a best effort thing. So the Peer Store does not guarantee that those addresses are going to be there, but that they're going to remain there forever until the pin is lifted. But it just, it's best effort. At one point, so yeah, there are some like GC considerations that we need to take into account as well. Another possibility, another design here is to force subsystems to keep pins alive by making them refresh those pins. So yeah, there's different approaches that we can consider here. But basically, the end functionality that we need is for addresses to not just suddenly vanish when subsystems are keeping track of particular peers, which is not too much to ask.
Jake, this kind of reminds me of something you were describing a while when we were in person at the lab week. The like user-defined topologies that I remember you describing something really similar to this, where you would say like, my subsystem cares about this peer or this set of peers, and then the Peer Store would make some decisions based on that. But,
yeah, so what we started building in JS was the ability for subsystems like PubSub and the DHT to register with the connection manager and say, I care about these protocols. And whenever a identify was done for a particular peer, that subsystem would then be notified of that peer, like, hey, you have a peer that you might care about. That peer could then do an analysis to see if it actually cares about that peer. So like, for example, like PubSub might decide that, it has all the peers that it cares about in its mesh, so it's not going to do anything with it. Or it could choose to like say, yes, I care about this peer. It would then inform the connection manager of that, and then the connection manager would prioritize that accordingly. And then as part of like topology registration, you could specify like what percentage of peers your subsystems care about. So you could be like, okay, the DHT gets 50%, the PubSub gets 25, and then we leave 25 open or whatever. And then the connection manager could then make more informed decisions about that. That was kind of like the playground that we were messing with for kind of a faux connection manager V2 experiment.
Cool. Okay, yeah, that makes sense. So it's not directly to do with the peer store, but I guess the peer store per se didn't exist in JS yet. So, but it sounds like a related kind of concept where we're saying, we want to register our interest in this particular peer or address, and yeah, give you an opportunity to just claim it, I guess.
Yeah, so in Go, we already have that functionality, but we emit identify events on the event bus. So whenever a peer is properly identified, a subsystem can subscribe to receive those events. So we kind of like decouple, the actual knowledge that the peer is conversing a specific protocol from the connection manager itself. But the connection manager is like super simple in Go right now. We haven't really evolved it since version 1. I'm going to post a link to a very strawman proposal that defines some loose ideas for what the connection manager version 2 could be going forward. I opened this like a lot of months ago and never really landed anything more concrete than this. But yeah, and I'm gonna post another link as well to some ideas for the next evolution of the peer store, so that everybody in this call is aware and have full context of potential refactors that are coming down the pike.
Cool. Any other questions around that? No? All right. We had one more item on the agenda pop up. I think that is Jarapo.
Hi. So I was making a small transport. It's just WebRTC, but instead of using a server for exchanging SDP, it uses a stream. So I have found a deadlock in Swarm, but I'm looking on that. More specifically, the problem is with the current Swarm implementation, it will always take the first transport to actually return a connection. So my transport, even if it will be faster than a relay, because it will require the relay circuit in the first place, it will never actually be used. So I want to know, is there anything planned to get the Swarm to know which transport is better than another? Because I think we can just add a small new interface with which extends the current transport interface with just functions such as how good quality, which return an integer. 0 is TCP, 1 million is quick, and -1 million is circuit, let's say. And simply the transport manager, the Swarm, will try to get the highest quality transport possible. So even if the first transport is, let's say, circuit, the Swarm will be able to know that circuit is a bad transport, and will they try to get a better transport? So even if circuit worked first, then a newer transport is working, he just checks the quality, and to see if the quality is bigger, it updates which transport is used for creating connection to that peers. And the fact with these things, we can actually make it quite seamless in the to upgrade, because if in the peer-to-peer transport function, if we see that the type is not a transport quality, just a transport, we can upgrade it depending of the function is I forgot, is proxy. If it is not proxy, if its proxy is false, we just leave it as 0 because we have no more information. We just, let's say, well, that's like TCP. If proxy is true, we can deprecate it. So it will actually be quite seamless. So all the transport was slower, but we will be able to add for things like quick or my transport, which is not good at quick, but better than circuit things. So the quality function just returns the int.
Oh, you're
So
muted.
yes. So the difficulty there is when do you stop dialing and when do you stop attempting to contact other? So when do you stop? So imagine you see yourself in the situation, right? You dial a peer via a relay. It succeeded. Then you have 3 alternative transports that you can try, all of which are better than the relay in terms of the quality or whatever score you assign to it. But none of them is actually gonna lead to a direct connection because the peer is not reachable, right? But still, you spend whatever seconds you have set as your timeout, as the connection timeout for those transports, trying to connect to those addresses, even though you already had a good connection to begin with that peer, and the only connection that would have worked in that context, right? So it's this trade-off between how much we willing to try potentially better scoring transports versus return the first connection that we have immediately, right? Ideally, ideally what you'll be able to do is like transplant a connection. So start off, and this is like we've discussed this in the context of.
Actually, with the currently peer-to-peer, we could quite easily, it's not that easy, but we can simply, when a new stream is created, I'm not sure if that's the case, but we can have just a UUID for each stream. And when a new stream...
I think we lost you.
Yeah.
Did everybody lose it? Yeah. We can't hear you, Harupa. Okay, yeah, we can hear you now.
Okay. Yeah. So I forgot. Yes. For migrating stream, that could be easily done. Easily, that's not that easy, but it's not that hard. We can just let's assume we receive. I will respond on the first part first about when to stop dialing. What I first think was just. When we do a connect, we try every transport possible. And let's say we have a timeout of 30 seconds. The first transport return. So if we return the connection, and if a newer transport, better transport return after that, newer connection will use the newer transport, but older connections that were already made with the slower transport such as circuit will actually stay on circuit, because right now we don't have any easy way to migrate. And for migration, we can just, when a new stream is created, send a kind of continue packet with an ID to the stream to replace, and the peer on the other end could just reset the peer to the connection, the stream to replace, and to acknowledge the changement of the stream.
Yeah, so ultimately, this would be the direction that we want to pursue, and the reason being that for hole punching as well, this is going to be important. So when you the way that we are conceiving hole punching is you use a relay as the signaler. So we already have relays, and you use the relay as a signaler, not actually in turn mode. So you don't actually pipe data, but in order to, okay, so imagine that you have imagine that you manage to establish a relay connection, right? You could potentially start exchanging data with that peer, and in parallel, start your hole punching procedure. If hole punching succeeds and you manage to establish a direct connection, you would ideally and transparently to the application, you would want to migrate all of the connection state and all of the streams onto the new connection, right? So this is kind of like transplanting the state of the old connection into the new connection, and this, in my opinion, would be the way to go forward. It is a complex thing. That's why it hasn't been implemented yet.
Yes,
but it basically,
that's what I'm trying to do. But I mean, I have that experience with the API, and I just took a look at Swarm, and oh my God, there's so many abstraction layers. But
all right, okay. Something that could facilitate a bit of this as well is the Swarm, the pipeline, and the I don't know if you've seen the pull request for the Yeah, so I think we need to land that. It's been open for a while, and there's a few comments that need to be implemented, and it needs to be rebased because master has moved as well. But definitely, I think that is going to make life a lot easier for these potential use cases, right? But the question, like, it's not going to ultimately solve the problem, which is we want to optimistically return a connection as soon as we have it, while we keep dialing other transports in the background,
Yes,
hoping that we'll find a better one, and then replacing the state under the hood, right?
yes,
That would be the ideal
require
solution.
another abstraction layer to actually switch connection. But I mean, is there already enough? But what I think we can already do, that's real, we can do easily, is instead of migrating connection, setting just newer stream to the better transport, and hope that older stream will just die away because connection will because protocol will close it.
I see what you mean.
Like setting like an affinity for this connection. It's like streams prefer this new one, but we're not going to mess with existing ones.
To provide a little bit of context, this is something we discussed with Steb as well in the context of all punching. So the simplest way to move forward is to basically create all new streams to the better connection and have a grace period for the older connection and eventually close it. Because transplanting the state of the stream from one connection to the other might be impossible, because the stream might be a quick connection and the other one might be a YAML connection. What are you going to do then?
Yeah, that's possible, but that's what we say. We need if we want to transplant, we need another abstraction layer between application stream and transport.
No, I would say don't even bother with transplantation, because it might be impossible in some cases.
I don't think it's worth the time, because it's really a lot of rewrite and.
Yeah. So I'm happy considering solutions that are way simpler. If we consider not transplanting, then what I would say is that we need some form of callback so that protocols can register to know when a second better connection has been opened for a peer, to which such that when they have an old stream, such that when they have a new stream associated with the old connection, they would be getting a callback. Telling them, hey, open a new stream again, or transplant your state. So that way you move like all of the concern of transplanting onto the application, and then they can find a checkpoint and move the state of the streams themselves, right? So if I'm the DHT and I open a connection to a peer, it's via a relay, which is not going to happen anyway, but we do that. Imagine it for this particular example. We open a connection to a peer. We open a stream on the over the relay connection, and in parallels, 5 seconds later, we manage to establish a direct connection. As the DHT subsystem, I would like to receive a callback, such that I know that when the request and flight over the old stream is over, I should close that stream and open a new one, versus keeping that stream alive, because then that new one would be open against the new connection.
Yes, so basically, if I understand, the idea is to implement a callback for subsystem to know when they should recreate a stream. And so, in fact, in reality, the transplantation will not be made by libp2p, but by the application themselves.
Exactly. The application would transplant the stream state.
I would like to give my blessing here, because I think that's the right way to go in terms of simplicity, so that we don't have any possible.
I didn't think into that, and yes, that's a good solution.
Yeah. So maybe a callback like alternative connection open or something like that. We have the event bus, right? So now it's very easy to produce these kind of callbacks, these kind of events.
Thanks. So that's perfect. That's what I wanted to know. Thanks.
I think this with the pipeliner, with a pipeline PR, which already dissociates or decouples the address, so the address resolution for a peer with the actual dialing and the execution of the dials and so on. I think this would make for a really, really nice dynamic system in the sense that we could keep trying things in the background. And the version of this dialer, or the let's say a configuration of libp2p that uses the right dial components in this pipeline could very trivial, like could easily keep attempting addresses in the background, even after having returned a particular connection, you keep attempting addresses. And if you manage to find a better connection, you emit the event, and that's it. Add the connection to your swarm, emit the event, and that's it. And then ref count the number of streams on the old connection to kill it when it reaches 0.
Yeah, yes, thanks. Can someone send me the pipeline PR, because I've not been here for a while and I'm not sure of what it is.
Yeah, I'll send that. I'll just post it in the chat window.
Thanks.
Great. That is it for the agenda items, and we are at time, a little bit over. So unless anybody has anything else, we'll probably skip the weekly updates. I'm gonna read those offline. No. All right. Nobody has anything. So I will leave the window open for a little bit so we can, there's the chat. I'll make sure this gets added to the crypt pad as well. Cool. All right, everybody, have a good week, and we will see you all next week. Bye.